Preparing for a hurricane involves several important steps. First, ensure the safety of yourself and your family. Secure your home by boarding up windows and reinforcing doors. Move valuable items to higher ground to protect them from flooding. Next, gather essential supplies, including food, water, medications, and a first aid kit. Have enough supplies to last for several days. Thirdly, it's crucial to have a reliable source of power. A generator can provide electricity during a power outage. Before a hurricane arrives, test your generator to ensure it is working properly. Familiarize yourself with its operation and safety guidelines. When using a generator, follow these safety precautions. 1. Always operate the generator outdoors in a well-ventilated area. Carbon monoxide is a deadly, odorless gas produced by generators. 2. Never run a generator inside your home or garage, even with the doors and windows open. 3. Keep the generator dry and protect it from rain and flooding. 4. Do not overload the generator. Check the wattage ratings of the appliances and devices you plan to power and ensure that the total wattage does not exceed the generator's capacity. 5. Use heavy-duty extension cords that are properly grounded and rated for outdoor use. 6. Never connect a generator directly to your home's electrical system unless you have a transfer switch installed by a qualified electrician. Backfeeding electricity into the power grid can be dangerous to utility workers and your neighbors. 7. Store gasoline and other fuel safely in approved containers away from the generator and any sources of ignition. 8. Turn off and allow the generator to cool down before refueling. 9. Have a carbon monoxide detector installed in your home and check its batteries regularly. 10. Be aware of the symptoms of carbon monoxide poisoning, which include headache, dizziness, weakness, nausea, vomiting, chest pain, and confusion. If you suspect carbon monoxide poisoning, get to fresh air immediately and seek medical attention. Power outages can occur during hurricanes due to downed power lines and damaged electrical equipment. Before the storm arrives, contact your local utility company to report any downed power lines or potential hazards. After the storm, do not approach downed power lines or flooded areas where electrical equipment may be submerged. Stay away from these hazards and report them to the authorities. It's important to stay informed about the hurricane's progress and any evacuation orders issued by local authorities. Monitor weather reports and emergency alerts regularly. If an evacuation order is issued, follow the instructions and evacuate promptly. Take essential supplies with you, including medications, identification, and important documents. Find a safe place to stay, such as a shelter or a hotel outside the affected area. When the hurricane passes, assess the damage to your property and report it to your insurance company. Take photographs or videos of the damage for documentation purposes. Be careful when cleaning up debris, as there may be hidden hazards such as broken glass, sharp objects, and contaminated water. Wear protective clothing, including gloves, boots, and eye protection. Avoid contact with floodwater as it may contain bacteria and other contaminants. If your home has been flooded, take steps to prevent mold growth. Remove wet materials as soon as possible and disinfect affected areas. Use fans and dehumidifiers to dry out the building. Consider hiring a professional mold remediation company to ensure that the mold is properly removed. Dealing with the aftermath of a hurricane can be challenging, but it's important to stay calm and focused. Seek help from friends, family, and community organizations. There are many resources available to assist with recovery efforts. Remember that it takes time to recover from a hurricane, so be patient and persistent. Stay positive and focus on rebuilding your life and community. Understanding the flow of electricity in a generator is essential for safe and efficient operation. A generator works by converting mechanical energy into electrical energy. This process relies on the principles of electromagnetic induction. The main components of a generator are the engine, the alternator, and the control panel. The engine provides the mechanical energy to turn the alternator. The alternator consists of a rotor and a stator. The rotor is a rotating component with coils of wire. The stator is a stationary component with coils of wire. When the rotor spins, it creates a magnetic field that interacts with the coils in the stator. This interaction induces an electrical current in the stator coils. The control panel regulates the voltage and frequency of the electrical output. It also provides safety features such as circuit breakers and overload protection. Generators typically produce alternating current, AC, electricity. AC electricity is the type of electricity used in most homes and businesses. The frequency of the AC electricity is measured in Hz. In the United States, the standard frequency is 60 Hz. The voltage of the AC electricity is measured in volts. The standard voltage in the United States is 120 volts for residential circuits and 240 volts for large appliances. When selecting a generator, it's important to choose one that is appropriately sized for your needs. Consider the wattage requirements of the appliances and devices you plan to power. Add up the wattage of all the items to determine the total wattage requirement. Choose a generator with a wattage rating that is higher than the total wattage requirement to provide some extra capacity. Generators are available in various sizes, from small portable generators to large standby generators. Portable generators are suitable for temporary power outages and outdoor activities. Standby generators are permanently installed and automatically start when the power goes out. They are connected to your home's electrical system through a transfer switch. A transfer switch allows you to safely switch between utility power and generator power. It prevents backfeeding electricity into the power grid. There are two main types of transfer switches: manual transfer switches and automatic transfer switches. Manual transfer switches require you to manually switch between utility power and generator power. Automatic transfer switches automatically switch between utility power and generator power when a power outage occurs. When installing a generator, it's important to follow all local codes and regulations. Hire a qualified electrician to install the generator and transfer switch. The electrician will ensure that the installation is safe and compliant with electrical codes. Regular maintenance is essential to keep your generator in good working condition. Follow the manufacturer's recommendations for maintenance intervals. Change the oil, air filter, and spark plugs regularly. Check the fuel level and add fuel stabilizer to prevent fuel degradation. Inspect the generator for any signs of damage or wear. If you notice any problems, have the generator repaired by a qualified technician. When storing a generator, drain the fuel tank to prevent fuel from becoming stale. Store the generator in a dry, protected location. Cover the generator to protect it from dust and moisture. Before using the generator after storage, inspect it carefully and perform any necessary maintenance. Understanding basic electrical concepts is helpful when using a generator. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical charge. It is measured in ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. The relationship between voltage, current, resistance, and power is described by Ohm's law. Ohm's law states that voltage is equal to current times resistance, where volts equals amps times ohms. Power is equal to voltage times current, or watts equals volts times amps. Understanding these basic electrical concepts can help you troubleshoot electrical problems and use your generator safely and effectively. Grounding is an important safety measure when using a generator. Grounding provides a path for electrical current to flow back to the source in the event of a fault. This helps to prevent electrical shock. Most generators have a grounding terminal that is connected to the generator's frame. To ground a generator, connect a grounding wire from the grounding terminal to a metal ground rod that is driven into the earth. The ground rod should be at least 8 feet long and made of copper or copper-clad steel. The grounding wire should be made of copper and should be sized appropriately for the generator's amperage. When using extension cords with the generator, make sure that the extension cords are properly grounded. Use extension cords that have 3 prongs: a hot prong, a neutral prong, and a ground prong. The ground prong connects to the grounding wire in the extension cord. This provides a path for electrical current to flow back to the source in the event of a fault. When using a generator in wet or damp conditions, take extra precautions to prevent electrical shock. Wear rubber gloves and rubber boots to insulate yourself from the ground. Keep the generator dry and protect it from rain and flooding. Never touch the generator or any electrical equipment with wet hands. Carbon monoxide is a colorless, odorless gas that is produced by generators. Carbon monoxide is toxic and can cause serious health problems or death. Generators should only be operated outdoors in well-ventilated areas to prevent carbon monoxide poisoning. Symptoms of carbon monoxide poisoning include headache, dizziness, nausea, vomiting, chest pain, and confusion. If you experience any of these symptoms, get to fresh air immediately and seek medical attention. Install a carbon monoxide detector in your home and check its batteries regularly. The detector will alert you if carbon monoxide is present in the air. Overloading a generator can damage the generator and the appliances that are connected to it. Overloading occurs when the total wattage of the appliances connected to the generator exceeds the generator's capacity. To avoid overloading a generator, calculate the total wattage of the appliances you plan to power. Add up the wattage of all the items to determine the total wattage requirement. Choose a generator with a wattage rating that is higher than the total wattage requirement to provide some extra capacity. When starting appliances, start the largest appliances first and then add the smaller appliances one at a time. This will help to prevent the generator from being overloaded. Surge wattage is the extra power that an appliance requires when it first starts up. Some appliances, such as refrigerators and air conditioners, require a surge of power when they start. This surge wattage can be several times higher than the appliance's running wattage. When selecting a generator, it's important to consider the surge wattage of the appliances you plan to power. Choose a generator with the surge wattage rating that is high enough to handle the surge wattage of the largest appliance. Voltage regulation is the ability of a generator to maintain a stable voltage output under varying load conditions. Good voltage regulation is important for sensitive electronic equipment such as computers and televisions. Generators with automatic voltage regulation (AVR) provide more stable voltage output than generators without AVR. Total harmonic distortion (THD) is a measure of the distortion of the voltage waveform. High THD can cause problems with sensitive electronic equipment. Generators with low THD provide cleaner power than generators with high THD. When selecting a generator for sensitive electronic equipment, choose a generator with AVR and low THD. Fuel efficiency is the amount of fuel that a generator consumes per unit of power output. Generators with high fuel efficiency consume less fuel than generators with low fuel efficiency. When selecting a generator, consider the fuel efficiency to minimize fuel costs. Noise level is the amount of noise that a generator produces. Generators can be noisy, especially when running at full load. When selecting a generator, consider the noise level if you will be using the generator in a residential area. Generators with noise reduction features are available. These generators are designed to operate more quietly than standard generators. Portability is the ease with which a generator can be moved from one location to another. Portable generators are typically smaller and lighter than standby generators. When selecting a generator, consider the portability if you will be moving the generator frequently. Maintenance requirements are the tasks that are required to keep a generator in good working condition. Regular maintenance is essential to ensure that the generator operates safely and efficiently. When selecting a generator, consider the maintenance requirements and choose a generator that is easy to maintain. Warranty is the manufacturer's guarantee that the generator will be free from defects in materials and workmanship for a specified period of time. A good warranty provides peace of mind and protects you from unexpected repair costs. When selecting a generator, consider the warranty and choose a generator with a comprehensive warranty. The National Electrical Code (NEC) provides guidelines for the safe installation and use of generators. The NEC covers topics such as grounding, wiring, and overcurrent protection. When installing a generator, it's important to follow all applicable NEC requirements. Article 700 of the NEC covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. These articles provide requirements for the installation and operation of generators that are used to provide backup power in the event of a power outage. NEC Table 310.15 B16 provides ampacity ratings for conductors. This table is used to determine the appropriate size of conductors for generator wiring. NEC Section 250.30 covers grounding requirements for separately derived systems. This section provides requirements for grounding generators. NEC Section 445 covers generators. This section provides requirements for the installation and operation of generators. Following the NEC guidelines can help to ensure that your generator is installed and operated safely.